In this example, we're asked to determine if the given infinite series converges or diverges, and if it does converge, find the sum of the series. This is an example of a telescoping series, where a telescoping series fits the form of this series here, where if we regroup the terms, we'll notice that many of the terms are opposites, and therefore they'll simplify to 0. So our goal here will be to find a simplified formula for the partial sum S sub n. Then, if the limit as n approaches infinity of the partial sum equals L, a finite value, then the series converges, and it converges to L. The series will also only converge if and only if a sub n approaches a finite number as n approaches infinity. So going back to our example, we'll begin by expanding the series to find the partial sum S sub n. So notice how the first group of terms in this series would be when k is equal to 2. So we'd have 1/2 minus 1/4. Next, k would be 3. So we'd have 1/3 minus 1/5. Next, k is 4. So we'd have 1/4 minus 1/6. Plus, when k is 5, we have 1/5 minus 1/7. And when k is 6, we have 1/6 minus 1/8. Next, we'd have, when k is 7, we'd have 1/7 minus 1/9. Of course, this continues, and the last term would be when k is equal to n. Let's see if we can find the last two groups of terms. Again, the last term would be when k is equal to n, which would be 1 divided by n minus 1 divided by the quantity n plus 2, which means the previous group of terms here would be when k is equal to n minus 1, not n. So when k is n minus 1, notice how the first fraction is 1 divided by the quantity n minus 1, and the second fraction would be 1 divided by the quantity n minus 1 plus 2, which would be n plus 1. Now let's begin simplifying and see if you can recognize the pattern to find a formula for S sub n. So we're looking for terms that are opposites. Notice here we have minus 1/4 plus 1/4. And then we also have minus 1/5 plus 1/5. Now let's pause here and say, for example, if we wanted to find the sum of the first 1, 2, 3, 4 groups of terms, notice how we'd have 1/2 plus 1/3, and then minus 1/6 minus 1/7. Notice how the 1/2 and 1/3 will never simplify out because these fractions are getting smaller and smaller. So to find the sum of the first 4 groups of terms, 1/2 plus 1/3 and the two fractions remaining are the second fractions from these last two groups. Now let's continue simplifying until we recognize the pattern. So next, notice how we have minus 1/6 plus 1/6. So if we wanted to find the sum of the first 5 groups of terms, again notice how we have the 1/2 plus 1/3 again, and the only remaining two fractions are these last two fractions from the last two groups, here and here. Let's go ahead and simplify again. The next two fractions to simplify out would be minus 1/7 plus 1/7. So if we wanted to find the sum of the first 6 groups of terms, notice how we have 1/2 plus 1/3, and then minus 1/8 minus 1/9. So again, we have the 1/2 and 1/3. The only remaining two fractions are again the last two fractions from the last two groups. So that's our pattern. If we continue simplifying through the nth term, the only two fractions remaining would be these last two fractions from the last two groups. All the other fractions would simplify out, which means the simplified formula for the partial sum S sub n would be equal to 1/2 plus 1/3, and then we have minus 1 divided by the quantity n plus 1 minus 1 divided by the quantity n plus 2. So now we'll take the limit as n approaches infinity of the partial sum S sub n. And notice as n approaches infinity, for these last two fractions, the denominators increase without bound, and therefore the value of these fractions both approach 0. And therefore the limit of the partial sum is equal to 1/2 plus 1/3. So if we obtain a common denominator of 6, notice how we have 3/6 plus 2/6, which equals 5/6. So because this limit exists, we know that the series converges, and the sum of the series is 5/6. I hope you found this helpful.